Hello friends, welcome to engineering tutorial. In today's video we are going to discuss an important concept associated with matrix, which is eigenvalues. Okay, so the eigenvalues of a matrix, it is a mathematical tool which has significance in various fields. Now we are concerned with the electrical, means significance in the electrical domain. Why should we study eigenvalues? Now the eigenvalues, it has a lot of importance in the control systems subject, where it is used to determine the poles of a system. We will discuss all of that in control system, but the point which I am stressing is that we are studying the eigenvalues. It has various importance in various fields, but in the electrical it is used in various ways. Control system is one of the examples, okay, where it is used to determine the poles of a system, which determine the stability or instability of the system, whether the system is stable or unstable. That is determined by the poles, the location of the poles. We will discuss all of that, but first let us understand about eigenvalues. Okay, let us say we have a matrix. We are considering a 2 cross 2 matrix, which is given by A11, A12, A21, A22. Okay, this is the 2 cross 2 matrix. Now we have to determine its eigenvalues. Now the characteristic equation for determining the eigenvalues is this: A means this matrix minus lambda. Okay, lambda is the symbol for the eigenvalue, multiplied with unity matrix. We have to determine this determinant value. It will come up in the form of an algebraic equation of order 2 or order 3. Then we have to solve it and to determine the eigenvalues. So the identity matrix or unity matrix, it looks something like this. Since it is a 2 cross 2 matrix, the identity or unity matrix will also be of order 2. So this will be like this. Okay, then lambda I means we will multiply this matrix with lambda. So this will look something like this. Okay, then we have to determine the A minus lambda I matrix. Okay, so this will be this minus this, so it will be A11 minus lambda, A12, A21, A22 minus lambda. Now by calculating this determinant value, we will get the eigenvalues. The determinant value will be A11 minus lambda into A22 minus lambda minus A12 to A21. Determinant is the cross product, not the cross, the product of the diagonal elements, principal diagonal elements, or the first diagonal or the leading diagonal, then the second diagonal. This is the determinant value is equal to 0. When we solve it, the values of lambda that we'll get, those are the eigen values. Okay. So, this is how we calculate the eigen values of a matrix. In this case, we have taken a 2 cross 2 matrix. Okay. So, just now we discussed about the basic concept related to eigenvalues related to a 2 cross 2 matrix. So, now let us take an example. Let us say we have been given a matrix 5, 4, 1, 2, and we have to determine its eigenvalues. Okay. So, let us call it as A. So, the eigenvalues is the determinant of this matrix. We solve this equation and we will get the eigenvalues. So, A minus lambda I matrix, first we have to determine that A minus lambda I, which is nothing but 5, 4, 1, 2 minus lambda 0, 0, lambda. This is 5 minus lambda, this is 4, this is 1, this is 2 minus lambda. Then we have to determine the determinant value of this matrix, which is the product of the leading or principal diagonal elements minus the product of the second diagonal elements, which is 5 minus lambda into 2 minus lambda minus 4 is equal to 0. Okay. So, let us solve it. 10 minus 5 lambda lambda plus lambda square minus 4 is equal to 0. Okay. So, now it is lambda square minus 7 lambda plus 6 is equal to 0. So, it is a quadratic equation and we have to solve it. So, plus square minus lambda minus 6 lambda plus 6 is equal to 0. We can split it in this way. So, minus 6 and 2 minus 1, it is 6, minus 1 minus 6 is minus 7. Okay, we have split it correctly. Then 2 lambda minus 1 minus 6 into lambda minus 1 is equal to 0. That implies lambda minus 1 to lambda minus 6 is equal to 0. So, the two eigenvalues of this matrix A are lambda is equal to 1 and lambda is equal to 6. These are the two eigenvalues of the matrix. Okay. So, this is how we calculate the eigenvalues of a 2 cross 2 matrix. So, I hope you like this video and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.